Okay, so chapter 10 is a long chapter. We have 6 sections, all right? The first section is kind of like an introduction to every type of conic section, okay? And then the 5 sections after that, every section deals with one conic section, all right? And the best way to deal with these is to kind of know the properties of each one. So what a conic section is if you like took a cone and you cut that cone into slices. Okay, you could slice one way and get a circle, another way you could get a hyperbola, another way you could get a parabola, and then another way you could get an ellipse. Okay, we've dealt with parabolas, but we haven't dealt with them as conic sections. We've just dealt with them as just a shape, a parabola. So in this section, 10-1, we're going to talk about kind of the properties of each and what they kind of look like. So first things first, we're going to talk about graphing circles and ellipses on a calculator. When you graph using a calculator, you always solve for y first. You cannot graph something that isn't solved for y. Okay? So, the directions state that we are going to graph and identify the intercepts and the center and what kind of conic section you have. All right? So, since we're going to graph these on a calculator, we have to solve for y first. So if I solve for y, I first have to subtract the x squared, both sides. All right, so now I have y squared equals 25 minus x squared. And I've got to square root to get rid of the square. And every time I square root two sides of the same thing, I have to have the positive and the negative answer. So I get y equals plus or minus the square root of 25 minus x squared. All right? Now, the plus and minus is super important because the positive will graph the top half of your circle or ellipse, and the minus will graph the bottom half of your circle or ellipse. Now, mind you, a circle is the same distance from the center to the outside of the circle all the way around. An ellipse is more like an egg, okay? So it might be taller top to bottom and then not as wide across or vice versa. So in order to get the plus or minus, you could graph a positive root in your y1 and a negative root in your y2. But you can kill two birds with one stone if you will graph it like this. You have a bracket on your calculator, and you can use the bracket to say a negative 1, comma, positive 1. That means a plus and a minus, okay? So if you want to graph the positive root and the negative root, you would do bracket, negative 1, comma 1, bracket, okay? And then you would put in your square root of 25 minus x squared. So we're going to do that. I'm going to go to my y equals. If you got something in there, take it out. So the little squiggly brackets are right here. You have the parentheses. So to get the bracket, I press second parentheses. That gives me a bracket. And I'm going to say, okay, I want the negative. Comma is right here next to your parentheses. So comma 1, and then close that bracket with the other side. And then you've got square root of 25 minus x squared. So if you'll pay attention when you graph this, it's going to graph the bottom first because I put the negative 1 first, and then it will graph the positive, and we'll be able to kind of see this. Now, I do want to point out that it kind of looks like an oval, okay? But if you look at the center, okay, which this would be the center, if I count, I've got 1, 2, 3, 4, 5 to the right, 1, 2, 3, 4, 5 to the left, 1, 2, 3, 4, 5 down, and 1, 2, 3, 4, 5 up. The reason it kind of looks egg-shaped, okay, is because your calculator is wider than it is tall. So these spaces between your tick marks are bigger left to right than they are up and down, and so that's why it looks like that. Okay? So we are supposed to identify the intercepts, so that would be x-intercepts and y-intercepts. And we're supposed to identify where the center is, which in this case is right here at the origin, and what kind of conic section it is. Since we know that from the middle here it's left, right, up, down, 5 either way, we know that this is a circle. All right, it has the same radius. Remember, the radius is from the center out to the side, so the radius would be 5 all the way around. That makes a circle. So I know that this is a circle whose center is at 0, 0. So center at 0, 0. All right, x-intercepts. I have 2 of those, right? So I'm just going to name those points, and if you look at it, well, we would look at it if it would come up. All right. If you look at it, it was at 5, 0 and negative 5, 0. All right, and the y-intercepts were also at the same places at 5, but that would have been at 0, 5, and at 0, negative 5. All right, and that's all the information that wanted. All right, so again, 5, 0, negative 5, 0, 0, 5, and 0, negative 5. All right, so let's look at another one. All right, again, I am solving for y so that I can graph it. So the very first thing I need to do is get rid of the 16x squared. So I am going to subtract 16x squared. Honestly, you really don't have to do a lot of fancy stuff here. You just have to know how to solve for a variable, which is something that you've done for a long time. So that leaves me with 9y squared equals 144 minus 16x squared. Before I can square root, I have to divide by 9, dividing everything by 9. And I don't want you to simplify if you can, okay? Just leave it because all you're doing is plugging it into the calculator. All right, so that leaves me with y squared equals 144 minus 16x squared over 9. And then I have to square root. And again, I don't need for you to simplify this. All I need for you to do is, get it done. You got to have the plus and the minus, okay? So I've got y equals plus or minus the square root of 144 minus 16x squared all over 9. So this is the square root of this entire fraction. Don't forget you have to have the plus or minus out front. So I'm going to go back here. I still want that plus and minus, so I'm actually going to go over and keep the root, but I'm going to delete everything that's under the root. All right, and I need a fraction, so I'll get me fraction boxes underneath there. All right, on top was negative 16x squared plus 144. So negative 16x squared plus 144. I think we had even written it as 144 minus 16x squared. That's fine too. It doesn't matter. You can put it exactly like it looks. And that was over 9. So again, it's going to graph the negative part first and then the positive part. So negative part and then the positive part. Now I realize it's kind of gapping right here, but it doesn't really. It actually goes all the way through. Now that actually looks more like a circle, but if you count from end to end, 1, 2, 3, 4, 5, 6 across, and if you go from top to bottom, 1, 2, 3, 4, 5, 6, 7, 8, it's actually taller than it is sideways, okay? So when it's taller than it is widthwise, then that means it is an ellipse. So that is what makes kind of an egg shape. All right, so this is an ellipse. All right, if you look at the center, all right, it's just right there in the middle. If you count halfway across, half of 6 is 3. 1, 2, 3 puts you right there at 0, 0. So center is at 0, 0. All right, we also have some x-intercepts and y-intercepts. So if I look at my x-intercepts, I've got one at 3, 0, one at negative 3, 0, and then I also have y-intercepts at 0, 4, and 0, negative 4. And that's all the information that they asked for. What kind of conic section, the center, and all of your intercepts. We have 4 of those total. All right, so that tells you what a circle and ellipse look like. So let's do one more kind of like that. So again, we're wanting to graph this, so I'm going to solve for this y right here. First thing I want to do is subtract the 9x squared. So that gets rid of that. I have 25y squared equals 225 minus 9x squared. Before I can square root this, I've got to divide by 25. So I will divide by 25. Again, since you're plugging it into the calculator, there's no need for you to reduce anything. You could reduce 225 over 25 and then do 9 over 25 separately, but there's no reason to do that. All right, and there's more room for error if you do that. And then I square root to get that y by itself, and I don't want to forget that I have to have positive and negative out here. So I have y equals plus or minus the square root of 225 minus 9x squared all over 25. So I am now ready to graph this. So I'll go back to my calculator to the y equals. And I want to keep the positive and the negative in the front. But I do want to take the stuff off the top here. All right. So I'm going to be graphing 225 minus 9x squared. And I need to take off that 144. And this is all over 25. And then I'm ready to graph. So again, it will graph the negative and then the positive. This one's going to be pretty clear what it is. It's a lot longer than it is tall. So if I count from side to side, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 across. So halfway would be 5. So our center is at 0, 0. And I've got 1, 2, 3, 4, 5, 6 up and down. So it's wider than it is tall, which tells me this is an ellipse whose center is at 0, 0. I have x-intercepts at 1, 2, 3, 4, 5, 0, and negative 5, 0. I have y-intercepts at 3, 0, and negative 3, 0. So I just need to record that information. This is an ellipse whose center is at 0, 0. I have x-intercepts at 5, 0, and negative 5, 0. And I have y-intercepts at 0, 3, and 0, negative 3. All right, so there's an example of a circle and a couple of ellipses, okay? And you can kind of see the difference between those, graphically anyways. So now let's go on and we'll talk about graphing parabolas and hyperbolas on calculators. So we already know what a parabola looks like. That's a U shape. And you're going to see pretty soon that a hyperbola is kind of like two parabolas pointing at each other. I like to say with their butts facing each other. That's, not technically correct, but it helps me remember it. All right, so we're going to identify the conic section, the vertices, and the direction that it opens. So instead of doing intercepts, we are now doing vertices because these do curve, all right, and point in some direction. But we still always solve for y. So in order to graph number 4, the first thing we'll do is divide by 3. That'll leave us with y squared equals x over 3. And then we'll have to square root. Again, we're not worried about simplifying. We're going to graph it anyways. Don't forget your plus minus. So we get y equals plus or minus the square root of x over 3. So I'll go to my graphing calculator to graph that. I still want the minus and the plus. And I am still square rooting, so I'll just take everything off of here. All right, and it was the square root of x over 3. So this will graph the negative side and then the positive side of this, and we'll be able to tell what it is. All right, so if you look at this, it looks just like a parabola, only instead of going up or down, it is going to the right. So you kind of think of this, excuse me, think of this side as like an arm and this side is an arm. So the arms are opening to the right, like if this was your body, okay? So this is opening to the right. This is a parabola because it's a U shape. And its vertex is right here at the origin. So that's all the information I need. This is a parabola whose vertex is at the origin, 0, 0. And it opens to the right. That's everything that it asked me for, so that's all I have to tell. Okay. Let's do another. Number 5. If I plan on graphing number 5, I have to solve for y. So the first thing I'm going to do is subtract this x squared. So that leaves me with a negative y squared equal to 4 minus x squared. I can't square root yet because there's a negative in front, so I'll have to get rid of that by dividing by a negative 1. I can just divide everything by negative 1. And since you're plugging this into your calculator, you really don't have to change anything. You could just leave it there, okay? If you did simplify, you would have a negative 4 and a positive x squared. And it's okay if you want to do that. I'm just going to leave it. And then to get rid of the square, I will square root, and not forget that I have to have the plus and minus. Got to have both sides. If you leave off one, it's going to look more like a log graph than it is a parabola. All right. So that gives me plus or minus the square root of 4 minus x squared over negative 1. Like I said, you could distribute that, but you don't have to. So we're going to go and graph that. I still want the negative 1 and the positive 1 out front. I'm still taking a square root. So I've got 4 minus x squared on top, and then on bottom I have a negative 1. And I'm ready to graph that. It's going to look kind of funny. This is something you haven't seen before, but this is the negative part of your graph. And this top part will be the positive part of your graph. And again, this does not stop. It rounds out. So if you look at this, this looks like one parabola opening to the right. This looks like a parabola opening to the left. Okay? And so this would be opening horizontally. If it was going up and then down, that would be vertically. Okay? So we're not going to say that it opens left and right. We're going to say that it opens horizontally. If it opens up and down, we'll say it opens vertically. So the things I need to know are what the conic section is, which way it opens, and its vertices. Now notice that this one has two curves, right? When you have a hyperbola, that's what this is called, you have two vertices. Okay? So I have a vertex right here at negative 2, 0. And I also have a vertex at positive 2, 0. So I have two of them. And notice that they're like equally distant apart right here with the origin. This one is. So that's all the information that I need. This is a hyperbola. It's kind of like hyper and then bola, but you don't say it like that. It's a hyperbola. It opens horizontally. Yes, spell that out. And I have vertices at negative 2, 0 and 2, 0. And that's all the information it needs. So if it looks like two parabolas, that's called a hyperbola. All right. Now let's talk about a couple of different things. Midpoint and distance formula. You need both of these. Midpoint formula tells you how the middle point between 2 points. All right, the distance formula tells you how far it is from one point to the other point. Okay, you will use these, all right, when you're looking to find, say, the center of the circle and you know 2 points on the circle, something like that. Okay, so you'll need to know those formulas. They'll be very helpful. For instances like this, we're supposed to find the center and the radius of a circle with the following points. So let's think about a circle for a second. So let's see. There's a circle. The center is equidistant no matter where you go to the side of the circle. Okay? So it really doesn't matter where these 2 points are. If I had one on this side and one on this side, halfway would be my center. Okay? It's the same thing if I had a point over here. This distance is the same as this distance. So it doesn't matter if I pick a point here or here. Halfway between here and here is still my center. So to find the center of a circle, you just need to know the midpoint between 2 points on the circle. Okay? So these are my 2 points. So to find my center, I'm going to use the midpoint formula. Okay? So the midpoint formula tells me that I take my x values and I add them together and I divide by 2. That gives me the x value of my center. All right? And I take my y values and I add those together, and that's going to tell me, and divide by 2, and that's going to tell me the midpoint or the center, all right, between those 2 points. This x1 and this x2, that just means this is the x of one point, this is the x of the second point. Same thing with the y's. This was the y of the first point. This is y of the second point. It doesn't matter which point comes first, but if this is x1, then its partner has to be y1. If this is x2, its partner has to be y2. So if I just plug into this, I'm going to add my 2 x's. So I have 3 and 9. And then I'm going to divide those by 2. And I'm going to take and add my y's. That would be 12 and 4. And I'm going to divide by 2. And when I do the math for that, that's going to give me 6, 8. So the center is 6, 8. All right, so we'll say this is 6, 8. Now, it also wanted me to tell what the radius was. Well, the radius is the distance from the center to a point on the circle. All right? So here's the deal. I know what my center is, and I know 2 points on my circle. I only need 1 point to figure out how far it is from the center to that point. So, in order to find the radius, you use the distance formula because you want to find the distance between the center and a point on your circle. All right, so I know I'm going to use my center, and then I have to choose. I can either use this point or this point. Either way, I'm going to get the same answer. It does not matter which one I use. So let's say that I'm just going to use 9, 4. That's a point on my circle. All right, the distance formula tells me that I'm going to take my x's and subtract them and then square that, and then I'm going to add that to my y's subtracted and squared. So again, this is the x from one point and the x from another point. So let's say this is x1, this has to be x2. If this is x1, then this has to be y1, and this is x2, this has to be y2. It just refers to a first point and a second point. Again, doesn't matter which one's the x1 and which one's the y1. All right. So I'm going to subtract my x's. So I've got 6 minus 9, and then I square that. Plus, I'm going to subtract my y's. So 8 minus 4. You have to do them in the same order. Okay. So if I use this x first, then I have to use this y first. All right, now if I do this underneath part, okay, you can plug that underneath. I get 25. And I know that the square root of 25 is 5. So my center was at 6, 8. And my radius was equal to 5. That's not hard math, but you're going to have to kind of think about it, all right, in order to get that right. All right, so we're going to do one more of those so you kind of get the gist of what's happening. I still want to know the center, and I want to know the radius. So to find the center, that's just halfway in between these 2 points. So to find the center, I use the midpoint. All right, so just to remind you, I'm going to write it here. I'm going to use the midpoint. So between these 2 points, I have to add my x's together, so 2 and 14, and divide that by 2. You're kind of like finding the average. And then I have to add my y's together, so that'd be 6 and 22, and divide that by 2. So that's going to give me the point 8, 14. This is 8. This is 14. So that's my center. To find the radius, that's the distance between the center and a point on my circle. So I have 2 options, okay, to find the distance. I can choose to use my center and the point 2, 6, or I can choose to use my center and the point 14, 22. It really doesn't matter, okay? You just have to remember which formula you're using. And if you think about it, the radius is a distance. All right, so that should tell you to use the distance formula. So I'm going to use my center, and then I've decided I'm going to use the point 2, 6. So I have to square root. I'm going to subtract my x's, so 8 minus 2, and then I have to square that. Plus, then I'm going to subtract my y's. Since I did 8 minus 2, I have to do 14 minus 6. And I'm going to square that. And if I do that, the underneath part, I'm going to get the square root of 100, which is 10. So my center was at 814, and my radius is 10. By the way, just for kicks and giggles, if the radius is 10, that makes the diameter 20. Remember, diameter is from one side to the other side. All right. So not a lot going on there. All right. So that is it for the introduction. If you go to the online book, there's a really nice video about conic sections, and he actually slices a cone. So you kind of get a visual of what each conic section is and where it comes from. So that's a good video to watch if you're wanting to look at something like that visually.